Year 322 BC. Greek philosopher and scientist Aristotle proposes a motion theory that the rate at which objects fall are proportional to their masses. He further states that a heavier object will fall 2 times faster than a lighter one. For example, a 10-kilogram object was said to have fall 2 times faster than its 1 kilogram counterpart. For thousands of years, nobody questioned Aristotle's theories and conclusions. For years, Aristotle's theories were irrefutable, and nobody dared to question them or their validity. This would soon change. Year 1582. Pisa, Italy. Italian philosopher Galileo Galilei begins to perform experiments, observations on the nature of falling objects. After countless experiments and observations, Galileo boldly and directly challenges Aristotle's theories of motion. He later discovered that objects fell at the same constant acceleration regardless of its weight. Legend has it that Galileo went on top of the Leaning Tower of Pisa to put his theory to test. No, Stefan, it's not the Leaning Tower of Pisa. This experiment was said to consist of Galileo dropping 2 objects of different weight but of similar shape and density from the tower. They both reached the bottom at the same time. Around 1590, Galileo concluded his theory and formulated a mathematical equation to represent what he was observing. The equation is one that is now often known by heart by a high school student who took physics. D equals 1/2 times g times t squared, with g representing the constant factor, the acceleration due to gravity on Earth, and it being roughly 9.8. This was a huge breakthrough for math and science at the time, as Galileo became one of the first thinkers to believe that the laws of nature are written in the language of math and science. Galileo's method of experimentation and measurement was revolutionary itself, but it was the theory that brought forth the idea of acceleration due to gravity and the idea that gravity, g, is constant. Galileo's thinking and theories would pave the way for thinkers and scientists, as they would use math and science to explain the laws of nature and the occurrences that happen in it. Despite all of Galileo's findings, people still believe that the heavier object falls faster than the lighter one. The most common example given to support that theory would be the brick and the feather. The brick seemingly falls faster than the feather when dropped, but simply put, this difference is mainly due to air resistance. Each object will experience air friction differently. The resistance on the feather is higher than the brick, but if both were dropped in a vacuum, they will reach the bottom at the same time, demonstrating that Galileo's findings were indeed correct. By 1638, Galileo was living under house arrest for having been previously condemned in 1633 for promoting the idea that the earth moved around the sun.